Stage 3 is the execute stage and is perhaps the most complicated. At a high level, it just has to use the ALU. How hard can that be? Oh yeah, sometimes it has to set the condition codes too. But it turns out that this is going to require lots of pieces of the processor. So the outputs from the register file, which we call val A and val B. Sometimes it's going to need val C. We're going to use the ALU. We're going to set the condition codes. And then we're also going to need some logic blocks to determine exactly what inputs will go into the ALU and also how to set the condition codes. So let's look at it. Here's our ALU. The inputs will be determined by two blocks of logic that we're going to call ALU A and ALU B. In the normal case, if we're doing, say, an ALU operation, those will just come directly from val A and val B. We'll call the output of the ALU val E for val execute. And then somehow the outputs of the ALU are going to set the condition codes. Now I mentioned that we're going to need val C as well. When do we need val C? Well, recall how we do address calculation. Address calculation is always an addition. And in particular, it's an addition of the constant that's in the instruction, the 8-byte quad word, plus the contents of the register referred to as RB, which gets read into val B. So when we're doing address calculation, we're going to use the ALU during the execute stage to generate an address that we'll use in the memory stage to access memory. Okay, how do we decide whether we should take this value from val C or this value from val A? Well, we clearly need another signal, which is our friend the opcode or I code, which is going to help us choose which of the two inputs to ALU A we want to use. Can you think of anything else that the ALU might have to know? I'm going to claim it also needs the function, right? The ALU does all our operations like add, subtract, multiply, divide. And how does it know which one of those to do? Well, it has to take it directly from the function. In the case where we're doing address calculation, recall that the function is always 0, and recall that 0 corresponds to add. So we can really just take the signal directly from ifun and have it tell the ALU what it has to do. How convenient is that? It's not just convenience. It's actually very explicit design in how we pick values to represent things like the function. We're going to stop here and ask you a question because I really want you to think hard about other kinds of input that you think the ALU might need.